Hello students, welcome to Learner's Planet, Theory Session 6 of Acids, Bases and Salts. In our previous session, we discussed about the methods of preparation of sodium chloride, its properties and its uses. We also discussed about the methods of preparation of sodium hydroxide, right? Now in this session we will discuss about the properties of sodium hydroxide and its uses, right? So coming to the properties of sodium hydroxide, students, it is sodium hydroxide is a white deliquescent solid. I told you in my previous session what is deliquescent. Deliquescent is the substance which absorbs water from the surroundings, right? And it also exists as a hydrate, as a dihydrate or a trihydrate, okay? So it is deliquescent solid, that is, it is absorbing large amount of moisture or water from the surroundings. Clear? Its melting point is 591 Kelvin, that is 318 degrees centigrade. It is stable towards heat, that is, it has no effect of heat on it, or the heat has no effect on it. It is soluble in water, fine. Heat is evolved due to the formation of hydrates, that is NaOH, NaOH2H2O. Right? It is soluble in water as well as heat is evolved. So children, here heat is evolved means what type of reaction it is? It is an exothermic reaction. Got my point? Now, as it is an exothermic reaction, why this heat is evolving? Because of the formation of NaOH, H2O and NaOH2H2O. That is the hydrates. Am I clear? Aqueous solution of sodium hydroxide is alkaline. Alkaline means it is basic in nature. We all have done. Why bases have got basic properties? Because they release OH minus ions or hydroxide ions in solution. Clear? So its aqueous solution is alkaline as it dissociates into sodium ions and hydroxyl ions in water. And it's a strong base. I also told you about the criteria of strong and weak. Strong is what? Which undergoes complete dissociation and the concentration of hydroxyl ions is high. Clear? So here it's a strong base. Concentrated solution of sodium hydroxide, when comes in contact with the skin, breaks down the skin and flesh into pasty mass. Right? So that is why it is called as caustic. There is one more caustic compound, that is called as lunar caustic. Have you heard about it? Lunar caustic. It has got a very good name, lunar. I'll tell you. Lunar caustic is caustic. This is silver nitrate. Now why it is called as lunar caustic? Because when it comes in contact with the skin, it burns the skin, right? And it forms this shape, right? So this is just like moon. That is why it is called as lunar caustic. Caustic means causing burns. So lunar caustic is silver nitrate, AgNO3. It's just an example I wanted to tell you. Okay, so these are the properties of sodium hydroxide, right? Now we'll come to its uses, where it is used. In the commercial production of soap. What is soap, students? Soap is sodium salt of fatty acid, right? So what is a soap? It is sodium salt of fatty acid. So this is your soap, right? So there what is done is that fatty acid is mixed with sodium hydroxide and a soap is formed. It is used in the preparation of paper, as it is a strong base, so this can be used for a number of commercial productions, so commercial compounds. Paper, viscose rayon, that is artificial silk, organic dyestuffs and many other chemicals. Okay, it is also used in refining of petroleum and vegetable oils, in the purification of bauxite for the extraction of aluminium from it, as a reagent in laboratory. Now this bauxite is a new term for you, right? Now what is this bauxite, children? Bauxite is an ore of aluminium. I'll write here bauxite. Bauxite is an ore of aluminium and its formula is Al2O3 2H2O. Okay, now this bauxite, as it is found in the earth's crust, it is composed of number of impurities, large number of impurities. So those impurities are removed by using sodium hydroxide. Clear? So these are the uses of sodium hydroxide. Moving to our next compound, that is bleaching powder. It is also called calcium oxychloride. Its chemical formula is CaOCl2. Okay, calcium oxychloride. Bleaching means, bleaching is an oxidation, that is, you must be knowing that when we put bleaching powder over some stain, it gets removed off. Why? Because it gets oxidized, right? Or the colored substance gets decolorized. Why? Because the color gets oxidized. Now what is the bleaching agent here, students? Is it oxygen or is it chlorine? In case of this bleaching powder, what is the bleaching agent is chlorine. Bleaching agent is chlorine here, right? That is, whenever it comes in contact with water, what will happen is that CaOCl2, calcium oxychloride, will react with water, giving you calcium hydroxide, CaOH twice, and chlorine will be released. Now this chlorine, students, is a bleaching agent here. This chlorine causes bleaching, right? So this is your bleaching powder. Now let's see its method of preparation and its properties. So how it can be prepared? It can be prepared by the action of chlorine gas on dry slaked lime. Slaked lime is what? Calcium hydroxide. So by the action of chlorine gas on dry slaked lime, this can be prepared. The chlorine produced as byproduct during manufacture of caustic soda is used in the preparation of bleaching powder. I told you, children, that the chlorine gas or the chloride ion which is formed at anode evolves as chlorine gas, right? Now that chlorine gas can be used for the preparation of large number of compounds. One of the compound is bleaching powder, right? Now this particular reaction or this process is carried out in Hessen-Clever plant. This is a plant where this manufacture of bleaching powder is carried out, right? What is the reaction here? Slaked lime, that is calcium hydroxide, is treated with chlorine gas or chlorine gas is passed through it. Then it forms what? Calcium oxychloride or the bleaching powder and water, right, students? So this is the way how your bleaching powder is prepared. Now what will happen? Your bleaching powder will come in the form of solution, that is bleaching powder with water. So what can be done is, it can be just filtered off, right? So this is how your bleaching powder is prepared. Now let's take up the properties. it is a yellowish white powder, right? Now, action of air on bleaching powder. When exposed to air, it reacts with carbon dioxide present in air, forming calcium carbonate and chlorine. Okay, so the only compound with which bleaching powder is reacting is what? Carbon dioxide. So here is, students, bleaching powder plus calcium plus carbon dioxide will give you what? Calcium carbonate and again a chlorine gas. Clear? Let's see one few more properties of this, that is solubility in water. This bleaching powder is soluble in cold water, right? That's why it is used for bleaching. Due to the presence of unreacted slaked lime, the water appears milky. How this slaked lime is formed? Bleaching powder with water will form what? Slaked lime, that is calcium hydroxide and chlorine. Now, due to this calcium hydroxide, the solution appears milky. Clear? Let's move to our next properties, that is action of acids on bleaching powder. It reacts with dilute hydrochloric acid or dilute sulfuric acid, liberating what? Chlorine gas. Right. So in the beginning only I told you that bleaching powder has bleaching properties due to the presence of chlorine gas. Clear? So bleaching powder, that is CaOCl2, this is also called as what? Calcium oxychloride, reacts with sulfuric acid, forming what? CaSO4 plus H2O plus again the Cl2 gas is liberated. My point is clear? Now here calcium oxychloride will react with hydrochloric acid, forming calcium chloride, water and again Cl2 gas is liberated. So every time in every reaction, children, what is happening? Chlorine gas is liberated. Right? So this chlorine gas has got oxidizing property. Now the question arises, if chlorine is the only agent responsible for bleaching, why not use chlorine instead of bleaching powder? Why to spend money for manufacturing bleaching powder? This is because it is difficult to store chlorine. It immediately reacts with atmosphere. It is highly reactive. Right? That is why chlorine is used in the form of bleaching powder. Clear? Now let's see its uses. It is used for bleaching everywhere. The bleaching means for just decolorizing a substance, for oxidizing a substance, for removing stains, all those things. So in textile industry for bleaching cotton and linen. In paper factories for again bleaching wood pulps. Wood pulps have got their specific color, that is brown. So on that brown we can't write, right? So for that what is done is that the color is being removed. Okay. In laundry for bleaching washed clothes, that is for bleaching, I think it should be dirty clothes, because you can't, washed clothes if there is any stain on the washed clothes. So that bleaching powder can be used. If the stain is left on the washed clothes, or it can be used on the dirty clothes also to remove stain, right? So it would be better if it is like for bleaching clothes, right? So this would be a better option. Now we have another use, that is for disinfecting drinking water. What is the use for disinfecting? How it is disinfecting? Again with water it is releasing what? It is releasing chlorine gas. That chlorine gas is an oxidizing agent, right? So this chlorine gas, what it does is it oxidizes the proteins or the enzymes present in the microorganism. My point is clear? So whatever protein or enzyme is present in the microorganism is oxidized by chlorine and your water gets disinfected. right? Now, nowadays these purifiers like Purates, they are using chlorine powder. So chlorine is chlorine is a very good oxidizing agent, and so what it does is it oxidizes the proteins or the enzymes of microorganisms. So that is used for disinfecting. Clear? That is also used for manufacturing of chloroform. Chloroform, you all must be knowing, it is used for anesthesia in medicine, for anesthetic purpose. So bleaching powder can be used for manufacturing of chloroform, right? It is also used as an oxidizing agent in the chemical industries. So remember children, its oxidizing property or the bleaching property is due to chlorine. Is my point clear? It is not due to oxygen. Okay, so oxidizing property or bleaching property is due to chlorine and not due to oxygen, right? Now there is a reaction given, that is bleaching powder reacts with sulfuric acid giving calcium sulfate, and again here is the chlorine gas. So the main agent in the bleaching powder is chlorine gas. Clear students? Now let's move to our next compound, that is sodium hydrogen carbonate or baking soda, right? Sodium hydrogen carbonate is also known as baking soda, okay, or sodium bicarbonate. Clear? It decomposes on heating to generate bubbles of carbon dioxide, right? So method of preparation. It is produced on large scale by treating cold and concentrated solution of sodium chloride. Again, aqueous sodium chloride is called as brine, with ammonia and carbon dioxide, right? So here it's sodium chloride plus ammonia plus water plus carbon dioxide, okay? And what is it giving you is sodium bicarbonate and ammonium chloride, right? That is, from here the sodium bicarbonate can be filtered off and can be used, okay? Now let's move to its properties. There is also the same thing. Now the properties. The sodium bicarbonate is a white crystalline solid. You must have seen baking powder at home. Or yeah, it also contains some other compound, but the major constituent is the sodium hydrogen carbonate, okay? Its solution in water is alkaline. It is sparingly soluble in water, that is very less soluble in water. The solubility of sodium hydrogen carbonate increases with the rise of temperature. So it's sparingly soluble means it is slightly soluble, and its solubility is dependent on temperature, right? Now let's check out why its solution is basic in nature or alkaline in nature. Now children, if I write here sodium hydrogen carbonate, that is NaHCO3, and in water it will get dissociated and form Na plus HCO3 minus, right children? Now we have got water also, so this water will be dissociated to form H plus OH minus ion, right? So your Na plus, which has been formed, will react with OH minus ions and will form what? NaOH, okay? And your HCO3 minus ion will react with H plus ion of water and will form what? H2CO3, right children? So which is a stronger one? This is a strong base, and this is a weak acid. Am I clear? So we can say that sodium hydrogen carbonate is weakly acidic and its solution is alkaline. Remember this thing, this is very, very important. Right? Now let's take up few more properties. No, we are taking up uses now. So it is used for making baking powder. Right? How? Baking powder is a mixture of sodium hydrogen carbonate and a mild acid like tartaric acid. Right? When baking powder is mixed with water and then sodium mixed with water, what happens? Sodium hydrogen carbonate reacts with tartaric acid to evolve carbon dioxide. Say, when we are mixing, when we are putting in baking powder in our cake dough or our cookies dough, what happens that the baking powder will react with H ion. From where it is coming? It is coming from tartaric acid, right? And it will be forming sodium ion, carbon dioxide and water. Now this carbon dioxide, students, gets trapped in wet dough and makes the cake soft and spongy. Now why we should use tartaric acid here? Why not only NaHCO3? Just tell me why we are using tartaric acid. Why not only NaHCO3? The reason behind this is that if I am using NaHCO3 only, assuming that only carbon dioxide is of use, what will happen? That on heating, NaHCO3 will dissociate, forming Na plus ion plus of CO2 plus of H2O. Okay, now this Na plus ion, what will do? It can react with OH again, forming sodium hydroxide. Here as acid is present, what will happen to sodium ion? It will react with tartaric acid, forming some sweet substance or some pleasant substance. But in this case, as tartaric acid is not present, what will happen to sodium? It will react with hydroxyl ion and form sodium hydroxide, right? Which will make our cake bad in taste. Okay? So is my point clear? Why are we taking tartaric acid? Because this tartaric acid is furnishing H plus ions. This reacts with H plus ions and forms Na plus CO2 and water. This Na plus ion again reacts with tartaric acid, the compound, and gives a pleasant smell to the cake. Okay? So we can't make baking powder of sodium bicarbonate only. Okay, children? So remember this. This can be asked in your objective type questions. Now the next use of sodium bicarbonate is sodium hydrogen carbonate. Sodium hydrogen carbonate is used in fire extinguishers. Right, that fire extinguisher is called as soda acid type of fire extinguisher, right, in which sodium hydrogen carbonate is used, that is called as soda acid fire extinguisher. Fire extinguisher. Right? Now in this what has done is that your sodium hydrogen carbonate and sulfuric acid is taken in separate containers. Right? So in the fire extinguisher there will be two containers. In one of them what will be taken is sodium bicarbonate and in other the sulfuric acid. Right? Now when it is operated, that is when the plug is pushed, what happens? Sodium hydrogen carbonate mixes with sulfuric acid present, releasing carbon dioxide. Okay. Now that carbon dioxide, because of that carbon dioxide formed, what will happen? There will be pressure inside the cylinder. Are you getting my point? What is happening? First of all, when the cylinder is pressed, when it is operated, what happens? sodium hydrogen carbonate or sodium bicarbonate will mix with sulfuric acid, right, releasing carbon dioxide. I'll write the reaction here. That is NaHCO3, that is sodium bicarbonate, will mix with what? Sulfuric acid, H2SO4, and it will form what? Na2SO4 plus H2O plus CO2. Got my point, students? So what is happening here is, now let's balance this. This is Na2SO4. I'll put a 2 here. Okay. Now how many water molecules are there? There is one water molecule. I can make it 2H2O and I can make it what? 2CO2. Right? Now what has happened? Your carbon dioxide gas has been formed. Now what this gas will do? This gas will increase the pressure inside the container, right? Now the pressure of this carbon dioxide gas forces a stream of liquid to fall on the burning substance. Okay, now this carbon dioxide forms a blanket around the burning substance. Now once your burning substance is covered by this carbon dioxide gas, what will happen? The oxygen supply to the burning substance will be cut off. Am I clear? Carbon dioxide forms a blanket around burning substance, thus cutting the supply of air to the burning substance. Once that blanket has been formed, there will be no more air provided to the burning substance, right? So when there is no oxygen, what will happen? The fire will stop. So this is used in fire extinguishers, right children? Now let's take a few more uses. That is, in medicines it is used as a mild antiseptic for skin diseases. It can be used as an antacid in medicine. Why as an antacid? Because it is giving out what? Base. It is slightly basic in nature. So it can be used as an antacid, but in very, very small amounts. Okay. It can be also used as a reagent in laboratory. Am I clear? So these are the uses of sodium hydrogen carbonate or your baking powder or your baking soda. Fine. Now I'll conclude this session. In this session we discussed about the methods of preparation of bleaching powder and its uses as well as properties. And also we discussed about the methods of preparation of sodium bicarbonate or baking powder.